Hello class. We are working through chapter 3 right now, week 3, chapter 3. So this chapter focuses on numerical descriptive measures, and there's a way to break down those measures. The first is measures of central tendency, and the first most common way to measure central tendency is with a mean. Okay. Now, in this class, you're going to have to do mean 3 different ways. Okay, so the most common way is a rhythmic mean. Okay, and with a rhythmic mean, the values all play an equal role. Okay, and then your mean is just your balance point. Okay, and the way we calculate that is with something that looks like x bar. We say x bar, and that is just the sum of my values divided by the number of values. Okay? So this is practice with this in the first page of your worksheet, where you have x bar equals the sum of your values over the number, and there's about 10 different values, and you add them all up and you divide by 10. It works similarly whenever you're looking at your average in this course. So we have, you know, test 1, test 2, project, and final. Adding all of those up and dividing by 4. Okay, so that is the most common form of mean that you'll see. There's also another type of mean, and this is called geometric. And geometric mean, you have to multiply all of your values together. So say we have the following. Let's say we have 3, 4, 2, 7, and 6. Okay, to find the geometric mean, you would multiply these numbers. So you would get 3 times 4 times 2 times 7 times 6. Okay, multiply those together, and you get 1,008. Now, what you would then do is you take the 5th root of 1,008, because I had 5 data points. And whenever I do this, I get a geometric mean of 3.98. Now, if you did a regular mean, if you did a arithmetic mean of these data points, you would get a different answer than 9.38. Okay, now, this one is most commonly used to interpret or to determine performances that result in investment portfolios. Okay, so a lot of times in finance and stuff, you'll see this used more commonly. Okay, now I have one more mean to put up here, and I'm running out of room, so I'm going to erase okay, so the last mean that we have to do is a weighted mean. Okay, and weighted mean is a good tool whenever you have outliers. Like, let's say you have a lot of different numbers, and one of them is just really odd. So you have something like 300, 400, 500, 300 again, and then out of left field you have another data point of like 5. Well, if I added all of these up, the 5 is going to pull down the average a lot more. It's really like an outlier, right? Okay, if I pulled a weighted mean, it gives me a better representation of the central value, and that's really what we're trying to find with mean. So for your test, you make sure that you can do a weighted mean, a arithmetic mean, and a geometric mean. Okay, you may be asked all 3, and they're all covered in the handout that I've posted for chapter 3. Okay, now we're going to move on to the next measure of central tendency,